everyone! Today we're talking about more characteristics of parabolas. Some of them we've heard before, some of them are new. So, let's get started with this parabola here. We're first going to look for the vertex. The vertex, again, is the spot in the middle of our parabola, right here, where the graph changes direction. So it was going down, it switches, and now it's going up. In this particular problem, the vertex is 1, -3. So we're going to go ahead and write that as a point. There's our vertex. Next, we're looking for the y-intercept. We haven't talked about y-intercept before with parabolas, but it's the same as y-intercept in any graph. It's the place where we cross the y-axis. So this is my y-intercept. And you just look at what number that's at. So that is at -2. So my y-intercept is -2. Next, you're looking, does this have a maximum or a minimum value? We're talking about a maximum or a minimum value for y. So when you look at this graph, there's arrows at the top here and the top here. That means this graph is going to go up forever. It never stops going up. So there's no maximum value because the graph just keeps going up forever. There is, however, a minimum value. There is a lowest point on the graph. It is the vertex. The vertex is also my minimum value. And when you talk about the minimum value, you're actually talking about the y-coordinate of the vertex because that's the lowest point the graph will get to. So my minimum value here is -3. Next, we're going to discuss domain of a parabola. Now, domain is possible x values. If you look at this parabola, there's an arrow on the left side and an arrow on the right side. That means that it keeps going on forever on the left and it goes on forever on the right. So there is no limit to our x values because there's no limit on my left or right coordinates. So my domain is all numbers. For parabolas, your domain will always be all numbers unless there's some kind of word problem or real-life situation, or if you're given a graph and there's no arrows. If you're given a graph with arrows, or if you're given an equation or something with a parabola with no real-life situation, then the domain will always be all numbers. For range, this parabola has a minimum value. It has a lowest possible number that the y-axis can be. If you look here, my lowest possible number that it gets to on the y-axis is -3. It doesn't go below that. None of these numbers below that are possible. Above that, it keeps going, but this is my minimum. So my range is y is greater than or equal to -3. It has to be above -3, so all of my y values have to be greater than or equal to -3. On your homework, I was unable to put the equal to line on any of the problems. So on your homework, please just pretend that all inequalities have a little line underneath them, since I was unable to put it in there. Okay, let's look at our second parabola. So if you look here, here is my vertex. The vertex here is at 2, 1, 2, 3, 4, 2, 4. So that's the vertex. Your y-intercept in this case is right here at the origin, which is 0. So it crosses the y-axis at 0. Is it a maximum or a minimum value? Well, there's arrows at the bottom. So it keeps going down forever. So there is no minimum to this graph because it just keeps going. Maximum, there is a maximum, there's a highest point, and that's the vertex here. So the maximum value is the y-coordinate of our vertex, which in this case is 4. That means the highest value that y can be is 4. The domain of this parabola is all numbers because there's an arrow on the left and an arrow on the right. The range, if you look here, there's a highest possible number that we can get to on y, it's 4. All of the other y values are beneath that. So my range in this parabola is y is less than or equal to 4. So now we've discussed how to find those characteristics on a graph. Let's talk about finding maximum or minimum value from an equation. To find maximum or minimum value from an equation, you have to do 3 steps. The first step is you have to figure out, does it open up or down? Opens up looks like this. The arrows are going up. If it opens up, that means there's a positive leading coefficient. So that means the number in front of x squared is positive. And that also means that it's a minimum value. Because if we open up, that means there's no maximum since our arrows are going up, but there is a minimum. There's a lowest point on my graph. On the other hand, if it opens down, that's like this type of picture. That means there's a negative leading coefficient, so the number with x squared is negative. And that means that you're going to have a maximum value. If we're opening down, my arrows are going down, so that keeps going forever, but there's a highest possible point on this type of a graph. Now, once you know if it opens up or down, you know if it's a maximum or a minimum value. Then you have to find it. To find it, the first step is to use x equals negative b over 2a to find the axis of symmetry. This is what we did yesterday. Then you're going to plug that number in for x in the equation to find the actual maximum or minimum value. So let's try it. So in this problem, this is my leading coefficient, and it is positive. So this means it opens up. Since my leading coefficient is positive, we're going to have something that looks like this, which means I'm going to have a minimum value. So I'm looking for a minimum. Okay, first I'm going to use my formula from yesterday, x equals negative b over 2a. This is a. This whole thing, including the minus, is b. Remember, b is the coefficient of x, a is our leading coefficient or our coefficient of x squared. So I'm going to do x equals negative b over 2a, and I'm going to plug stuff in. This means that x equals negative 10, because I'm plugging in the whole negative 10 for b, over 2 times 4. Okay, this is then x equals negative makes positive, so 10 over 8. We can simplify that to 5 over 4. And even though I like fractions, it's actually easier if you then go ahead and make that a decimal. So this would be 1.25. Okay. So my axis of symmetry is x equals 1.25. Now that we have our axis of symmetry, we're going to plug that into our equation everywhere there's an x in order to find your minimum value. So here, I'm going to do it over here. So we're going to do f of 1.25 equals, and then everywhere there's an x, I'm going to plug in 1.25. So this would be 4 times 1.25 squared minus 10 times 1.25. Notice I put the 1.25 for both of these x's. So now we're simply going to figure out what these equal. So I'm going to do my exponents first. 1.25 squared is 1.5625. Then I'm going to multiply. 4 times 1.5625 is actually 6.25 minus 10 times 1.25 is 12.5. and then I subtract those, 6.25 minus 12.5 is negative 6.25. This number won't always match this number, it just happens to in this problem. So my minimum value here, if I go back up here, my minimum is negative 6.25. And that's how you find a minimum value without having to graph it. Again, you follow the steps, determine if it opens up or down, so that you know if it's a maximum or a minimum. Then you use the formula for axis of symmetry, and then you plug that in for x and solve it to find the maximum or the minimum value. All right, have a great day, everyone. Email me if you need help.